Good morning, IB Math. Moving on to Chapter 6. Gosh, this is a long chapter, isn't it? We've done a lot of videos, a lot of short ones, well, long videos, but short lessons. Certainly, the textbook only does 1 or 2 pages on a concept, and we need half hour to 45 minutes. We need to do a lot more work than the textbook is giving us. Kind of one of the difficulties of trying to fit in all the things that the textbook wants us to do, all the things that are in the IB curriculum, in the amount of time that we've got. Very, very difficult to do. Today we're going to look at inverse trigonometric functions. What is an inverse trigonometric function? Well, inverse trig functions come whenever we have something like this. Suppose I have the sine of x equals 1/2. Well, this is saying the sine of some angle is a half. If I do the inverse tangent, tangent. Where did tangent come from? The inverse. Now, there's 2 ways of noting this. I can take the arc sine of both sides, arc sine of 1/2. So I'm taking the arc sine of both sides, arc sine of sine. One of the ways in English of reading arc sine, what angle has a sine of? What angle has a sine of the sine of x? Well, just x equals the arc sine. What angle has a sine of 1/2? And of course, that's what this is saying, isn't it? Do you remember your unit circle? You should be able to answer this one pretty quickly and easily without doing too much work here. What angle has a sine of 1/2? And of course, it is pi over 6. But wait a minute, there's more. Because sine is also positive in the second quadrant. There's an angle in the second quadrant that has a sine of 1/2. And it is 5 pi over 6. But wait a minute, there's more. Pi over 6, what if I went a whole 2 pi around again? So if I went 12 pi over 6 around again, I would get 13 pi over 6, 25 pi over 6, 27 pi over 6, and so on. And the same thing here. If I went 12 pi, I get 17 pi over 6, and so on. So in general, we can say that this is pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n, where n is some integer. N could be 0, and I get the answers between 0 and 2 pi, or 1, so 2 pi later, 2, 4 pi later, 6 pi later, 8 pi, or negative 1. What about that way? There's answers that way as well. So the idea of arc sine. Now, arc sine can also be written a couple of different ways of writing arc sine. Let me see, I'm looking for a pen here. There's a blue pen. I can write arc sine of x as the sine to the negative 1 of x. So this is inverse. Whenever you see arc or inverse sine, be careful. Sine to the negative 1 of x does not mean 1 over sine of x. Okay, so be careful with that. All right, let's take a closer look at the inverse trig functions. All right, so here's how we're going to do this. First, I'm going to look at the sine of x. Now, a graph of the sine of x, and I'm going to graph it from negative 2 pi to positive 2 pi. And sine sine looks like that. So that's what sine looks like. What would inverse sine look like? The inverse sine, or arc sine, would be if I took this and I reflected it over the x-axis. So all of the x-intercepts become y-intercepts. The y-intercepts become x-intercepts. And then all of a sudden, so this thing is going from negative 1 to 1, and pi over 2 pi, 3 pi over 2, and 2 pi. The inverse sine looks like this. This would be the first quadrant. There's inverse sine. Now, the first thing that should jump out at you is, while sine is a function, inverse sine is not a function. It's a problem. Inverse sine is not a function. So when we're talking about inverse sine, and we saw that in the previous one, the inverse sine of 1/2, there was a whole bunch of different answers. I don't want to have a whole bunch of different answers because that means this is not going to be a function. So when we look at inverse sine, we're actually going to look at something called restricted inverse sine. Restricted inverse sine, let me add a page here. There we go. So from now on, whenever we look at inverse sine, I want you to think about restricted. We're only going to look at one part of inverse sine, the part that makes it a function. We're going to look at this part right here. So whenever we're talking about inverse sine, we're only going to talk about angles between 0 and pi over 2, first quadrant, and between 0 and negative pi over 2, which is the fourth quadrant. So restricted sine, and here's another way of thinking about it if I do the unit circle, inverse sine is only going to count angles in the first and fourth quadrants. Restricted sine. So if I say find the sine of an angle and it's positive, it'll be the angle in the first quadrant. Find what angle has a sine of and it's negative will be in the fourth quadrant. We want to avoid having all those other possible answers. So sine, inverse sine, not a function. So we're going to restrict it. Whenever we talk about arc sine or inverse sine, we're only going to talk about this part of it. We're going to ignore everything else because this is a function. Passes vertical line test. So basically just the first and the fourth quadrants. All right, let's take a look at cosine. And we're going to see the same situation happen in cosine. In cosine of x, the graph of cosine, and I'm going to graph it from negative 2 pi over 2 to positive 2 pi over 2. And cosine graphs here and here and here and here and here. That's clearly a function, passes vertical line test, right? But what about inverse cosine? Well, if I take this and I flip it over the line y equals x, flip all the x's and y's, reflect over the line y equals x, either way you want to think about it. Oh, those are a little close. Not very good graphs today, I'm afraid. So let's see. One. I get that. And again, clearly, inverse cosine is not a function. So we're going to restrict ourselves when we talk about inverse cosine. So from now on, whenever we see cosine to the negative 1 of x, we're going to restrict it. Restricted cosine of x is only going to be negative 1 to 1 is only going to be this part right here. What quadrants is that? What angles are we restricting ourselves to? Well, remember, this is negative 1 to 1. This is going to be pi over 2 and pi. So restricted cosine, in effect, if I think about it on the unit circle, this is first quadrant and second quadrant. So when we talk about restricted cosine, we're only going to talk about angles in those two quadrants. So if I try to find the cosine of an angle and the cosine is negative, it's going to be a second quadrant angle. and if it's positive, first quadrant angle. Now I know that cosine is also positive down here, but to make it a function, we're only going to pick the one value here if it's positive and the one value there if it's negative. Restricted, oh gosh. Terrible, terrible, terrible. So here's cosine, inverse cosine, but whenever we talk about arc cosine, restricted cosine, we're only going to talk about the angles right here in the first and second quadrants. All right, let's take a look at tangent. Tangent x. Do you remember what the tangent of x looks like? I'm going to graph it from negative 2 pi to positive 2 pi. And of course, tangent's a little bit more interesting. It's got the asymptotes in there. I've got an asymptote here, and here, and here. 1 over 0 is undefined. I've got x-intercepts, and then I've got this. There's tangent. What would inverse tangent look like? Well, an inverse tangent is kind of fun and kind of interesting here. In inverse tangent, I have the asymptote x equals 1. The inverse of that would be the asymptote y equals 1. I'm sorry, pi over 2, right? Pi over 2. Pi over 2, pi over 2. 3 pi over 2, 3 pi over 2. Negative pi over 2, negative 3 pi over 2. And of course, tangent is going to look like this. My x-intercepts become my y-intercepts become my x-intercepts. There's inverse tangent. And clearly, again, inverse tangent is not a function. So whenever we're going to do inverses, we're going to talk about restricted inverse tangent. So now let's talk about tangent, but restricted. Whenever we talk about inverse tangent now, we're not going to talk about all of it. We're going to restrict ourselves to the following graph. Now notice, this is a function. This is not a function. This is a function. Oh, and don't confuse this with like the cubed root or something like that. The cubed root doesn't have asymptotes. The cubed root keeps going on forever and ever and ever and getting bigger and bigger and bigger, where tangent has, inverse tangent has asymptotes. So if we're talking about inverse tangent, what two quadrants are represented here? What two quadrants are we talking about? Inverse tangent, restricted inverse tangent, if I do it graphically speaking, we're talking about the first quadrant and the fourth quadrant. So if the inverse tangent angle is negative, it's going to be a fourth quadrant angle. It's going to be something down here. If the inverse tangent is positive, it's going to be first quadrant. It's going to be some angle up there. So whenever we deal with the inverse, and I'm not going to do cotangent, secant, and cosecant. They're going to follow the same rules. We're not really going to see the inverses of the other three very much at all. I wouldn't worry about them. But we need to be able to, looking at these, figure out, just given this, these restrictions here whenever we're talking about tangent. So if I go back to the original problem, the sine of x solve, the sine of x is 1/2, if I take the inverse, or the arc sine of both sides, x is equal to the inverse sine of 1/2. Now sine is restricted, or I should say inverse sine is restricted to just first and fourth quadrant. It's positive, so just the first quadrant here. And of course the inverse sine is going to be pi over 6. That's going to be my answer. I'm not going to have to deal with the 5 pi over 6 and all the other iterations and all that other good stuff. All right, in the homework, you're going to have to look at, have to do a bunch of these. You probably want to have your unit circle handy. So I want you to do homework 6-P, which is on page 420, and it's assignment numbers 1 through 5. Now you might want to keep your unit circle nearby, and remember the restrictions for inverse sine, inverse cosine, and inverse tangent. You're also going to need your calculator. It's going to ask you to graph a couple of things and take a couple of sinusoids apart that we did in the last chapter, a couple of review things, looking at a sinusoid, graph it, and then tell me what is its period, what is its amplitude, what is the line of symmetry or the center line, what is the amplitude, how far above and how far below, what is the phase shift, moved left and right, and all that other good stuff. As soon as you're done with the assignment, go ahead and email it to me. We're going to keep going here, moving on, kind of finishing up the chapter, 6.Q. The next thing we're going to do is kind of take this, go to the next level, and we're going to talk about equations. The next thing we're going to do is we're going to put this all in the form of equations and solving equations, which, oh gosh, if you know your trig, if you know your unit circle, and you know all your identities, it's not that bad. It's pretty easy. But if you don't, it's a real struggle. Very important to know your unit circle really well and to know all the identities. The two things you want to keep in front of you is have a nice unit circle all done, put that over here, and have a list of all your identities on a sheet and put it over there. You could use the formula sheet. I know you've all got the formula packet, but the formula packet's got tons of other things in it. I would just create one nice piece of paper with the unit circle and the special right angles, triangles on there, and then another sheet with all of the angle identities on there, just to have it handy for doing all the assignments. And sometimes if you get a little bit lost and you're looking at a problem, and I'm going to talk about this in the next lesson, you look at something and I got no idea how to start. Well, don't. Just stare at the problem and then stare at your formula sheet. Is there anything on the formula sheet that jumps out that you can use? That might be a good place to start. All right, guys, good luck, and I will talk to you again soon. Bye.